and I shall start. Right, so I've started recording, and I will present. I can get that to present. And has that updated? No, it hasn't, because PowerPoint is annoying. Just a sec. I'll have to go into slideshow and settings and tell it no, I want windowed. Okay. Present in the window, that's better. Okay, so today I'm talking is going to be a more tutorial style rather than like a full lecture, and so I'm going to do a whole bunch more of code sharing, and we'll be looking at actual code, and we'll try and start setting things up, because for next week the tutors will help you finish this setup. I have a slightly different setup to other people. I know some of you have already complained about the number of different IDEs that you are having to use, and the hassle of having to understand more than one IDE. Now, yes, I understand the complaint, and yes, I know that it feels like you're therefore learning or spending time doing stuff that isn't what you feel learning is supposed to be. However, as a professional developer, a lot of your time is spent understanding tools and understanding how to combine tools and use tools, and having multiple different IDEs into those tools and APIs into those tools. So, in fact, if you really cannot stand using more than one IDE, then you're going to struggle in industry, because that's how life is. You will be changing platforms, you'll be changing systems, new systems will come through. So unfortunately, I know it's annoying, but you might need to use this as a practice for when that happens in workplaces. Now, I have been using, so we're in this course, I'm using OBS. We are going to try using OBS as our way of screen sharing. So what I want people to do is I want them to install OBS. Now, I haven't copied the instructions on how to do this from the Comp 102. We're also getting all of Comp 102 to install OBS on their machines, so that they can do screen sharing more easily in Zoom than is currently with the whole screen sharing and multiple shares and all that sort of stuff. Right, so I would ask you as second years to install OBS on your system. We also have a Node media server where we're going to look at that for proactive tutoring, which I'll discuss with the tutors and with the students through the next few weeks. But installing OBS is basically downloading it for your system, setting up a scene that has full screen, and then turning on the OBS virtual camera, and then that should pop up as a option in your Zoom, and so you can screen share without having to ask to screen share. So Javafx, we are using Javafx. This is the first year that the courses are using Javafx, so that's been a change from previous years. Previous years they've used a GUI Swing AWT wrapper, and you build it on top of that, and you have, you know, a bunch of odd GUI behaviors. It also was in the past that each object held how it was to be drawn. Okay, so if you look at previous code, or you look at other code, you might find people describing the idea of displaying code being with the object that is being displayed, right? So the graphics context gets passed all the way down, and deep in your data structure, each node knows how to draw itself, okay? Now, unfortunately, that breaks the model view controller pattern that's become the dominant pattern for development across multiple platforms, where we have a data model, like a database, or data structures which are independent of the way they are viewed. They just store data, right? And they are optimized and efficient, and they present an interface to people outside the internal structure so that outside parties can access the data in a reasonable way. So yes, basically what I'm saying is we are not using the ECS 100 library. For my code, I've removed all of that stuff, and I'm no longer using it. I'm going to try and convince all the other lecturers to move to this style of coding as well, but that takes effort, so I'm going to have that fight with them this trimester, and if you can support me, that'd be great, and so we can actually accept that moving into the modern Javafx is the better tools for you to use, seeing you've already understood some of the Java WAT and Swing stuff. So we're going to move into that AWT. We're going to move into Javafx. So I'll just shrink that down so I can see both chats. Right. So do chat to me. Right. This is very much a chat back and forth. I like Javafx because it uses web standards. So hi, thank you for saying hi. And we're also using, it uses CSS for styling. So any knowledge you gain from doing web pages and web development and all the styling tools for interfaces that you get through CSS, you can use in Javafx, right? So that can be a significant benefit. And if you know how to use CSS, if you don't, and someone says, "Oh no, CSS, it's horrible," you don't have to use CSS, right? You can directly write the formatting instructions. It just provides that as a way of doing styling. Also, because Javafx has a model where it can have a markup language, and Javafx markup language, which is Fxml, it allows us to separate the design of our GUIs from the code that implements interactions with that GUI. And so I can actually use WYSIWYG design tools. And I'm going to be using Scene Builder, and I use Scene Builder, and so I will show you that. Now, part of the reason to do that is because Scene Builder is very much like what you would see in Android Studio when you are creating mobile interfaces. The way that you do that in Android in Java is using a WYSIWYG tool. Now you can do it in code, but the standard way is to build it in the WYSIWYG tool. And so that's how we look at the part of the value. Also, Javafx is fully hardware accelerated, which can be quite useful. And so by following the pattern of keeping the graphics separate from the model, you can spawn off the graphics onto your graphics hardware and accelerate all of that, which gives you some advantages if you've got any GPU in your machine at all. And most machines do now. Even your mobile phone has a GPU now. And it fully supports the model view controller pattern. Now, have you guys been introduced to a model view controller pattern? Have you heard the term? No. Okay, right. So that will be, we'll have a whole tute and we'll discuss model view controller. Just a quick overview of this model view controller pattern. It's a design pattern, architectural pattern. Is the idea that you keep your data separate from your view, and you have code in the middle that controls those two. So your data doesn't have anything to do with the view. The view does not directly ask things of the data. It goes through a controller. Now, there are lots of ways in sort of React and lots of tool chains that use the model view controller, where the controller links the data model to a view and allows the view to access the data. But that's all coming through that controller. So the controller is the bit that knows about the view, knows about the data, and does the mapping between the two. But your data can be independent. So WYSIWYG, what you see is what you get, is the acronym for WYSIWYG, and it's just what you see is what you get. Was what's happened. My favourite one is actually Veronica as an acronym, which was a very easy rodent-oriented network connection something, right? So they made the word Veronica out of their rodent-oriented network system. Now, what Javafx does require is not core to the Java language. It is a plugin, which means you need the jar file somewhere in the class path when you are building your Java. So when you build Java, you know how it takes the Java files, turns them into classes. In that class, where those classes are, /class path, right, the path to those classes, also has other paths to other jar files or .class files that have been compiled that Java can use to interpret instructions. You can do that manually. I've been able to do that manually on the Linux machines in the lab. However, it's a pain to write it yourself. And basically, yes, if you were to copy the javafx.jar file, you would place it next to the class files the way you did for the ECS library. However, that's not the standard way of doing this. The standard way of doing this is because the jar file has been installed on the Linux machines, and when you install Javafx onto your machine, it will go onto your Windows machine. You'll put it in a directory somewhere, and you certainly don't want to copy that jar around and into every single project that you're going to do. That's, a waste. And so what we're doing is we're using the Visual Studio, so code in the lab machines, or Visual Studio code, to point to that jar so that you can build these projects. Now, I've done this for Javafx, and hopefully I've given you enough instruction in the Javafx, in the .settings and .launch, to be able, so you can point to the library correctly. So that's one of the things we'll be doing next week, is making sure that all of you can build the Javafx code that I'm sending out, so that as we update code and you've got the assignment, which is now out, you can build it. Well, you can't build the assignment because it's missing a whole bunch of code, but you can build these examples and start working with them. Is this PowerPoint available somewhere? Not yet. I will make it available on the lab page. Okay, so sorry it's not available yet. I will make it available. I know I should put it up before the session, so I'll try and do that in the future. But I will be making it available. I did put up yesterday's slides, so they are linked on the ECS page, right, on the wiki page. So the slides are up. Links. It should be in the attachments underneath. So maybe the link's dead, but I'll fix that. Okay, so it was hopefully in the attachments. Now you've told me it's broken, I'll go and fix it. Only the first lecture. You should have been the second. Okay. I will fix that. Javafx. So as I said, it's a jar file. If you're using Maven or another build tool, which is quite common once you get large Java projects, then adding Javafx into the standard Maven or Gradle, very simple. It just says, do you want Javafx? Bang, you just tick it, and it will go and find it and do all the building and make sure it's got the dependencies and all that sort of stuff. Visual Studio Code isn't a full IDE. It's actually a text editor with plugins, right? So it's Java. So Visual Studio Code allows you to code in C or Ruby or any of or any kind of other Python, whatever, JavaScript. With plugins, it will allow that text editor to do interesting things. It has plugins for Java. It links to your Java compiler. and it links to other tools. So you kind of, it's part of a tool chain that's an editor rather than being the whole chain itself, which is partly why I like it. It's lighter weight. It also does some nice features, like it has collaborative editing, where you can have multiple people looking at a single file. However, that's limited to about 5 or 6 people, so I can't really do that as this kind of lecture where I start up my server and all of you are looking at my code on your own Visual Studio systems. But we can connect code, we can look at each other, we can help each other with code in various ways. So we're gonna try some of these during the lab, so expect this to come up. Now, as I said, if you're on the ECS machines, are any of you actually in a lab currently? Sitting in front of an ECS Linux machine? Haha, we have one person. Right, fabulous. At least one of you is sitting in front of an ECS Linux machine. Visual Studio Code is there under Code, and you'll also find it in the application menu. You can just type code at command line and it will spin up. And so hopefully if you get the .settings and .json and .launch files correct in your repository, you open Code and you go and you point it at the root level of the code that you've downloaded from the GitLab. The Bluetooth earphones, that's your own deal. Okay, so with the lab machines, in user package Java, Javafx SDK 11 is there. It is usable. I've had it working and run it. I built a Linux fork for that. I'll just check that everything's recording properly. It does appear to be recording properly. Javafx also uses a tree structure, and given we're talking about data structures, this is kind of a bit meta. It's a tree structure of having a stage, which is the window you're displaying to. Within that, you have a scene. The scene holds that data. Now, if you wanted to change from a full layout to a new layout, you could switch scenes that you're in. Okay, so you can actually switch scenes, and so the stage points at a different scene, so you can swap out all of the formatting you have and bring in a whole new lot of formatting. Right, so that's kind of changing the scene. Within a scene, you then create a graph of nodes that have a parent node, which is usually a layout, and within that layout there are sub-layouts, and then within those sub-layouts there are leaf nodes. The leaf nodes down the bottom there are things like shapes or text fields or labels. Buttons are a leaf node, so those sit at the bottom, and above those there are layout options. So there's a border layout, there are flow layouts, there are grid layouts, there are a bunch of layouts. And I'll show you those in Scene Builder, and I'll show you some code for that. So we're going to discuss that. This will also come up in the lab because we're interested in getting you started and making sure that you can build and view the code that we're sharing. Okay, so this is also an ethical point of view here. Now, I know I am not the majority in this opinion, but I believe that all code should be in a repository. I don't believe you should ever have code that is nude, that is running around naked with no protection. All code, like PPE, should be protected. And so you should have it in a repository. And so I much prefer all code to be sitting in repositories rather than shared by zip. Now, I know other people share code by zip, and that is their prerogative. But my preference is to always have my code in version control. So I will be sharing all of my code that I share through the GitLab repos. I've done that with the assignment, and I've done that with this code. I shared those links. In later courses, we're still negotiating this course. In later courses, I've required people to submit their code as their Git in the Git repo rather than actually submitting anything. They just give me the link to the repo. I then go and pull those repos rather than actually having them submit code itself, right? So I would prefer to move to that, but we're still kind of working that through. So we'll work that out, but this is my preference. I know other people don't have that preference. Now, have you done much with Git, or do I need to have a big tutorial on Git on Monday? Right, so a little tutorial, big tutorial, nothing official. Okay, right, so I'm going to be the Git introducer to you. Great, okay. That will add some content to my tutorial next week, to make sure that I give you a really, like, we go through Git because it's a core skill, right? Using GitHub or GitLab. GitHub and GitLab are quite similar. Using Git and version control is a core skill for every programmer. So actually, to some extent, before I teach you anything else, I should be teaching you to use Git well. So I'm that it's all good. I'm glad that I can learn and help with learning Git. And there are, as people are pointing out, there are a bunch of tutorials out there. But we will be stepping through and helping you understand Git, because that's how I'll be sharing my code. When you go and have a look at that ECS Git repository, you will find that there is a link to that repository, and you can download the code as a zip if you want to, but you can clone the repository. Now, if you are part of the dev team, cloning makes perfect sense, because you clone it, edit it, and push it up. You are not part of the dev team, so when you clone the repo, if you make edits to that repository, so you may edit the code, and then you commit those to your local machine, and then you push those to me, it will go, no, you're not allowed to push to the assignment template, because the assignment template is not a repo that you're allowed to change. However, you could issue a pull request saying, hey, Simon, could you update your repository to look like this, right? So we're going to go through all of that. However, we're going we will talk more about Git, because that's a long discussion. However, you should just at this stage be able to either download the code or hit clone, and then start having a copy of that code locally from the GitLab. So if I click that link, right, it's not going to show. I'll have to switch to sharing my screen, which will be that screen there, and I will put the code over there, and then we can. That's the assignment 1 code. I want the now. Were people able to see the tutorial 1 code? Just as a check, I updated it 40 minutes ago. So, yes, great. Okay, so people have at least seen it there. Now, I'm going to add more content to it, and I'll add more to the README so that you have some more context. But I was just trying to get the code out so you could play with it itself. And we will look at what is in that code now. This is the code that you'll also be working with next week. In the tutorials, so don't worry that you don't understand everything when I'm going through it now. We will talk about it, and you'll get a second chance to play with it. I just want to give people access to it over the week, like now, so that you could start seeing what we'll be talking about. Okay, so I've only got a couple more slides to talk about, and then I'm going to switch over to actual code. So you're asking, do we have to use Javafx version 11 or is 17 fine? So on Windows, I'm using 17. On the Linux machines, it currently has installed version 11. As far as I can tell, there's not a problem. Okay, so on the Linux machines, I was using the default one. You could, of course, install your own Javafx locally, point to your own jar in your own jar path, and so you could move to an updated Linux install version. I just want to make sure that I support the current installed jar for the lab machines. Okay, and I will I will be checking that none of what I do is breaking in the 11 version in the Linux machines. If I do break it, certainly tell me. I will try and fix it. Okay. And there was. I've got to also bring up the Discord to make sure I'm not missing anything there. Excellent. Right. So yesterday I talked about an adjacency matrix. And so what I thought I'd do is I'd show you some code for an adjacency matrix. The code in the repo that I shared there was code that was initially designed around loading the graph, which is on the next slide, loading this graph using with text files where I wrote this graph out with weights because because some of you asked about the weights, so I put the weights in. So this has a CSV file, so comma separated value files, in the code that represents this graph, and then I've loaded it in using some lists and then displayed that on the screen. So what we're going to do is, okay, so we've got a question. I tried to install Javafx on my machine, but when I googled how to, all the websites I went to assumed I'd already installed it despite the name of their articles. Okay. That's partly what we're going to do on in the labs and with you in these tutorial times, is to get through the process of making sure you have Javafx running on the machine that you want to develop on. Either your home Windows machine or in the lab it's already set up. So that's what the tutorials will be there, will help you get that set up. You don't need Maven if you're using Visual Studio Code. You don't need Maven. I'm not using Maven. I'm just doing straight Javafx with the settings. And if you have Javafx installed, just install without Maven or any of those sort of things as a jar file in the path to FX that it suggests, then you'll be able to use my code without worrying about Maven or Gradle. Okay, so you don't need those. So if you're using Sublime, you could also probably do it straight. It's okay to use Eclipse. People can use Eclipse, that's fine. I won't be providing you the Eclipse default settings. You will have to import those in. And I believe you do have to set the Javafx path in Eclipse. But again, that's not actually that difficult to do. It's like a single line. Okay. So yeah, Sublime, I haven't checked with Sublime, but Sublime should also implement it relatively easily. So what we're going to do is I'm going to switch over to my second screen. So that and unfortunately the camera will be me looking sideways, but that's just how we'll do it for the moment. So if I go to that one, so yeah, hello. I'm gonna look this way because that's where my code is. I'm kind of looking at the code. It's just a wee bit down. Okay, so we have this code. I start with this code. So if you download this code and if I go to here, this code is in tutorial 1 with the link that I put out in both of the chats. And I need to turn that off and go to airport mode so that nobody interrupts me. So hopefully you got that link. You can go there. You should be able to therefore see this code. I down here in the README, I put an ability. Trying to show you the ability to go to code and highlight it. Which, if you go back to the README, if you can look at the README, and inside the README there is this piece of code that does that. I'll actually copy that and I'll put that back out as actual code so you can see it, and because this is a repository, it's going to ask me to write a comment, so adding code to link, and then I'm going to commit those changes. Okay, so now you can see that that's got the code associated with it. You don't need to see that code. This would be a link to the code in the repository to show off parts of the code. This is the code I will be looking at, and we're talking about the adjacency matrix, which I build here. And if I make that larger, you can see this is pretty standard Java code. I'm using Visual Studio Code, so what we're doing here is I have, if we look at Visual Studio Code, in the top corner here, I have the files which show off these files, right, that I have in the shoot subdirectory, right? So I know you weren't using packaging before. I tend to like to use packaging as a fairly standard Java thing to do, which means it puts your Java files down in a class area. Yes, so you can. Yes, so people are sharing various tools. That's all good. So this starts with a main file. So the main file is where Java comes into. It extends application, and so that's what Javafx is looking for when it's building like building your Java environment. Is looking for an application, so the Javafx application, and that will have a couple of things. It will have a start, which throws an exception, and down here it will have a main, right? So that's where you get your standard public static void main args coming in, and what Javafx does, it takes that main and says, right, launch using those arguments. Okay. Okay, people have shared the link again. That's great. Thank you for doing that. And there are links in the that will be up on the wiki as well. But you know, this is going to start for next week. But you can start playing with it now. So this code, I do a couple of things. So for example, if I run this code, right? So let's just run it and see what it does. So to run it, I can press F5, or I can go here and it says, what do you want to do? They've only got one launch app, so I'm going to press play on that. I could press F5, that would be fine. It's going to come up. It's showing me the call stack, running a bunch of threads, and it shows me this graph. Now, if you remember from the lecture notes, that looks something like, and if I go to OBS, I can show you that it looks something like that. Okay, so that graph is kind of similar to that graph. It's a bit squished, right? I didn't get the numbers perfectly right, but I created this graph. So it loads that graph. It allows me to move the graph up and down, left and right a little bit, which is what we're doing for the part of the assignment. I can zoom in on it, and I can zoom out with it, and I can click on these things, and they display the nearest neighbor code, right? So I've got some of that in. So you will need to be able to understand this and translate it for the other areas. I also have a load button, which allows me to pick an open node file where I can click the node file, and then it asks me for the edge file. I click the edge file, and that will reload the graph with the from those files. Now, that all makes sense? I created this graph, yes. So if we if we close this down, what I did, because I'm reading the content from a file, now in the lecture notes I gave you a horrible way of reading in a file, because I didn't actually read in a file, I just manually entered each node, which is a horrific way of doing it, and you should never do that. You should always be reading from a file. So what I did is here, the first graph, because in my root I have, and I suppose I should also mention this. We're a multilingual country, and therefore I believe that it is part of our job to make sure that we are supporting multiple languages in the work that we do. So I have added the local bundling system. All right, so this is a standard Java resource bundle where you can load a resource bundle. Now, in this case, I'm loading strings. You can also load other resources, including different images based on the get bundle that you are asking for and the locale you are asking for. So if you have different pictures, you can put those in a bundle with images and extract those images. This allows you to do different settings and different display and particularly right to left for different languages. So it allows all of that flexibility. It's the standard way that Java does bundling. And so what I'm looking at doing is having a locale load. Now this is currently English in New Zealand. I implemented the MI, which is the Māori localization. So we can have a Te Reo version. So when I press F5, we come up with some translations in the Te Reo version. I haven't translated these. I have translated those in the assignment. So you have up, down, left, right in Te Reo. But you know, I was working through that process. So that's what this first bit of the stage does. The first bit says, hey, load the languages. The next bit says load an Fxml file. Okay, so the Fxml file, if we have a look in the code, is in here. So this is the Fxml file. This has actually been generated. I didn't hand write all this. I actually started by hand coding the Fxml file, and then I started using Scene Builder so that I could actually do it do it more efficiently and do it using the WYSIWYG tool. But as you can see, this is an XML file. These are various things that help the XML file understand what's going on. So note the Ian given has these directions written in Māori. Yeah, so that's what I was trying to do. And you know, I'm wanting someone out there to help me with the Māori translation. I could do the Norwegian because I lived in Norway for 11 years. I could translate all of the code into all of the interface into Norwegian, but most of you won't. That won't help you. But if someone could help update those string texts and translate those with me, that would be fantastic. So in the Javafx, basically what's happening here is we're seeing buttons being created. There was a load button, there's a quick button, some zoom in buttons, up and down, left, right buttons, and the search buttons and a label, so text fields and a label for display. It creates some constraints which I didn't create. Apparently this is what Scene Builder adds to your code. And at the bottom there's a canvas which I called map canvas, and I give it a known height and a width, and it's got an on mouse clicked event. Now what this hash handle mouse click does is it goes and looks in my controller code, and it knows where the controller code is from looking at the top here, where we have the controller code. So this section at the end of the introduction to the Fxml file tells me which class is the controller for this file. Okay, so when we go and have a look at the graph controller at the top, and this is unfortunately quite a large file, we can break it down in smaller files. I was trying to keep it a bit simpler. So graph viewer with your PS4 as a controller. Interesting. So in the graph controller, to match the Fxml file, we have all of these fields which we create. They all have the @fxml start saying, hey, this is actually defined elsewhere. And so I will link to the definition in that Fxml file. It's private for the controller. And then I have the same name here as is in the Fxml file. So if we have a look, we have a fxid, which is the load. Okay. Now, if we look specifically, So the English version have the directions written in Māori instead. It would be nice to have those written in Māori. I can work on. We can discuss that, right? We're going to try and improve things. So if we can improve things, that would be good. And any suggestions, I'm happy to make alterations. So the key to using the language feature is actually in here where it says what text will be displayed on that area. You can see the widths and heights, and for some reason it thinks that should be 74. That should probably be a 75. This is saying quit. If you put a % in front, that tells Fxml this code, the actual text for this code will come from the resource bundle rather than directly. And so when I see this % load in the text, it actually goes into the into here and goes, okay, you have the word load. That should be written with the capital word load if it's in the English, and with Utania in the Utana if you're doing in Te. Now, of course, this was my initial translation. I'm happy to change it because it's probably wrong. So people help me. I'm also trying to learn more today. So that is the loading. It loads in that GUI. That GUI, if I show you Scene Builder. Now, I know this is coming through quite fast, but what we'll do is you'll get to play with this code. If you've got the code there yourself, then you can be using it. Open project. And I will load the Tute 1 source comp Tute Fxml. Let me be open. Okay, so this is Scene Builder, and what it does, right, is it gives me the GUI layout and all of the types of things that I can add. So it has various containers. I can click in here and I can see what we currently have on the canvas. I can make those edits. You can see these have got the % node listed, whereas these are just up and down. So you don't need Scene Builder to build anything. This is just a GUI visualizer that would save that Fxml file. It's not actually required at all. You can write an Fxml file entirely by hand. This is just the GUI that I used to build that file. Okay, so you don't need it, but you should be able. If you've just got Javafx, you should be able to run the tutorial. So that's what we're going to work through next week. Is practice, see if you can get it running. And if you can't, then we'll have the tutors help with us with that next week. So, just going through this code. Do we have questions? More questions? Not really yet. Okay. It will be helpful to help people get up to speed, because some people will have got. I assume some people have got the code working and running. Did anybody get the code working and running? No. I've got 4 no's. 1. Yes. No. Okay. Right. Okay. Right. So you're still working through. Okay. So no one's actually using this code. Yes, Javafx is certainly available on the Mac. You can download Javafx on the Mac. Right, so most people are going to look at it after the lecture. If you're in the lab, you should have been able to get some people had lecture 2, which I put up in the lab working, and that's so for people sitting in the lab. What you might need to do is if you point code at this. There are instructions at the top of the settings and the launch file that tell you where the path to FX is. And at the moment I'm using the environment variable, So you need to install Javafx and set the environment variable. Otherwise, you can copy. I said that path is where my path on my local machine is in Windows. So in the launch and the settings are where you need to change. So this is pointing at where I installed Javafx, right? When I installed Javafx, it said, where do you want to put it? So I put it under Javafx 17.1. You could be using 17.2. And so in Windows, it'll be something like that. You can put it anywhere you like, but that's how you add additional reference libraries, is in Visual Studio there. If you're in the Linux machines, that's the path you copy and paste into there to have that it compile. Okay, and if you've got the launcher, you would then copy and paste either, if you've set up your paths correctly that way, if you've done an export path equal that, or you just copy and paste this bit and put it into here for the Linux machines. Okay, but if you're on a lab machine, we'll have, I don't know how many of you will be in labs at the moment, but that's how you do it for Linux, and that's where you change it for Windows, right? So yes, we will be going over this more next week. But what I want to do is just quickly, not the class file, jump into the graph file, because go into the controller. So as I said, you get those controller files, know about the Javafx. So what is it saying? Yeah, so nobody's had their labs yet, right? So I'm introducing you to this, but you will be having your labs next week, right? Nobody's had their labs so far. Nobody's gone tutorials yet, so the labs will be coming up. I'm going through this initially to kind of talk about it. If you can get it working, great. Otherwise, we will be helping you, making sure that everybody's stable. People are wanting me to do a step-through video. Well, maybe that's this afternoon's job, is to do a step-through video for how I would install Javafx on a Windows machine. The challenge is, of course, I've already installed Javafx on my Windows machine, so I'll have to grab my other Windows machine and do a fresh install, so you will see so I will be showing you what you would see. Okay. Yeah, so I'm going to have to go and take my other Windows machine, blitz it for content, and then do a video of installing this from scratch. I'll do a recording of that this afternoon, therefore, and put that up into link that in, possibly also whack it up on YouTube, just so people can find it more easily. I do not have a Mac. I cannot give you a way of doing this on the Mac. However, hopefully seeing it on Windows, you could kind of get the vague idea of what's going on. So that should be all fine. Why do I have advertising on my screen? Oh, sorry. That is a notification from Steam, because I haven't really plugged into Steam. Sorry, I didn't mean to have that up. That's actually just my Steam popping up. So sorry about it. It might have been Epic. I forget which one was. I've got various things stored in. Sorry, I didn't. I'm not being paid by anybody. I didn't intend to have that ad up. If you're watching me on Twitch, the ads on Twitch are not my fault. It's just that's what Twitch does. So there are some. I'm streaming to Twitch as well. So absolutely not sponsored. And don't give me any bits. I don't need any of that. I'm being paid for this. Right. So we've got. Oh, actually, I'm supposed to finish at 53, aren't I? Given that I'm not a Twitch partner, I'm a Twitch affiliate, because haven't got enough subscribers to get to a partner. But as an affiliate, yeah, they still advertise on your channel. Okay, so what I know that I've now run out of time, and this will be continuing Right, so you'll be continuing to see this code next week, and I have a meeting with the tech tutors. And we'll work through the code with it. Partner on Twitch stages. So we've now run over time, and there will be other people. You probably will have other things to go and get to. The one thing I wanted to show you is actually the data structures and algorithm bits of this. Is that I have a graph structure, an edge structure. So the edge nodes, very simple connections. You'll be looking at this next week. And I have a node structure which holds the node's location and its name and ID, and just some getters and setters and a toString and some equals and just very generic code. And the graph is where we actually do the interesting data structure storage. The graph is where we have currently, these are used for reading in the edges, and this is an adjacency matrix which I build using build adjacency matrix, which is down here, where it goes through, it creates an adjacency matrix, it goes through the edge list, because it's led in all the edges into a long list of edges, and then stored those by doing the get from, get to, and add await, and it's actually made it bidirectional. This was because I was making it bidirectional. If we made it just singly directional, I would take that one out, right? So you would only have one of these two. So if it's a directed graph, then the edge would be just one of those two. So I would save that. You'll see that I've got it's saying, hey, you've done something. You changed it to multi, and you deleted that line. I will add the message directed graph and confirm that with a tick, saying that yes, I wanted to make those commitments. And now I'm going to sync, which is me pushing that code to GitLab. So the GitLab version online will update with those changes. So it will change it to Maori by default, and it will change it to it will make it just directed graph. And now once that completes, there it does, I can go back to the here, which shows me the tutorial 1, and if I look at the code, I could step into that code, and I'll just go and show you. I know you all have to leave, but if I go and have a look at the graph code, you'll see now that it only has that single line, because that's the line I removed, and so when I pushed it up, it took the content from my machine, pushed it onto that repo. Okay. Will the other lecturers be using Git? I know it's nearly 12, so some of you will be rushing off to another class. I'm going to actually encourage them to do this. In later courses, absolutely lecturers will be using Git in third year. In fact, for group work, one of the standard features is that you are given a repository which all of you have access to for your group. So absolutely this will be used in third year, and some of the second year lecturers will also be using Git. So it's certainly not idiosyncratic to me. Okay, so go play with that code. I'll put the links up. We'll try and get you working in Javafx next week, so you can run the code, you can display the code, you can see the code. So hopefully that will all work. If you're in the lab, if you're in the lab, and I'll put this in more clearly in the README. What you might want to do is I will add a Linux branch, which will have the Linux installed so that you can run it. You can check out the Linux version of the code, and it should all have the Linux stuff in the right way. Okay, so I shall stop streaming, and I'll start recording.